In class today, we'll look at writing linear equations. We've had a day of practice on this already, so it's looking at, again, different ways to solve problems, and then how can you use writing inequalities to help. So here's the task for today. When looking at the past season, Kelvin, a basketball player, scored no more than 12 points a game. He scored 2 and 3-point shots. What are all the possible combinations of 2 and 3-pointers that he made? Can you represent the solution in multiple representations? So if we take a look at a table, again, you have to define variables. So in this case, we have 2-point shots and 3-point shots. I'll just call X the number of 2-pointers, Y the number of 3-pointers. So again, there's multiple ways to find answers to this. And if you look, like since he can score no more than 12 points a game, there's also multiple solutions. So when we look at it, one way is to make a table, right? So if you have your number of 2-point shots plus your number of 3-point shots, it should be less than or equal to 12. So when we're making a table, we just have to keep that in mind. So for example, let's say we score 0 2-point shots. How many 3-point shots could we score? Well, 3-point shots, 3 points, and it has to be less than 12. So we could score 4 3-point shots, and that would be equal to 12. We could score 1 2-point shots. So then the question is, how many 3-point shots could we score? So we could score, we wouldn't be able to do 4 again. Could we do 3? So 3 times 3 is 9, and then plus 2 more, that's 11. So that would work. Could we score 1 2-point shot and 2 3-point shots? And we could, because that would be less than or equal to 12. So we would have 2 plus 3 times 2, which is 6. So that would be 6, 7, 8 points. We could score 1 and 1 and so on. So if you notice, there's going to be, if you make a table, many different solutions. We could graph those solutions. So again, if this is the number of 2-pointers, this is the number of 3-pointers, you could score 0, 4. You could score 1, 3. You could score 1, 2. You could score 1, 1, and so on. So as you're graphing and making a table, you'll notice that there's many different solutions for this basketball problem. Now the inequality, I kind of wrote one right here, but if we add in the value, the number of 2-point shots, so 2 points for every 2-point shot, plus 3 points for every 3-point shot should be less than or equal to 12. So here's an example of the inequality. And really the main goal of today, again, is to practice writing that inequality. So here, this is the goal. Can you take words right here and write an inequality? And then we're going to take a look at, all right, once you have that inequality, how can we then solve it without making a table or a graph, or even with making a table and a graph? How does that inequality help us to solve a problem like this? So again, the main goal is, can you write your inequality? And a few definitions. A system of inequalities is simply 2 or more inequalities. Just like a system of equations is 2 or more equations. Constraints are restrictions. They're like limitations, boundaries, and so on. So let's talk about what that looked like for Kelvin's problem. So for Kelvin, there would be one inequality that we wrote, the 2x plus the 3y should be less than or equal to 12. But there's some constraints that we can add to make our system right here. So a constraint would be like, can you score negative points? And you can't. So the number of 2-point shots has to be greater than, or it can be equal to 0, right? You can score 0 2-point shots and more than that, but you can't score negative. And you could also say, all right, what's the highest amount of 2-point shots? So really we could do something like this, where x has to be between 0 and how many would make that less than or equal to 12? That would be 6 shots, right? 2 times 6 is 12. So a constraint right here would be the number of 2-point shots has to be between 0 and 6. For 3-point shots, it's the same thing, right? We can't score negative 3-point shots. We can score 0 3-point shots. What's the highest number of 3-point shots that we could score? Well, if we plug in here, 4 would be the highest number because 3 times 4 is 12. So this system of inequalities is, like, again, 2 or more inequalities, and the constraints are just what's the lowest, what's the highest. So it kind of deals with domain and range there. And then it says, what are some strategies you can use to write linear inequalities? So think about that as you do the assignment, which is, can you take these words and write the inequalities? So we'll do the first one together, and then you can have two to try on your own. So the first one is Ezra, one of my students who used to work at Rainbow, but he would tie-dye shirts and sell them for a profit. So let's say Ezra had $100 saved up from a batch of previous tie-dye sales. And also from working at Rainbow. He's going to make his next batch of merchandise to sell and would like to purchase some more sweatshirts and t-shirts today. He found that this one store gives him a pretty good deal on these items if he spends a minimum of $50. The store sells t-shirts for $5 and sweatshirts for $10. He wants to buy at least twice the amount of sweatshirts as he does t-shirts. So there's a lot of words here. I just went through and highlighted, like these are the things I'm probably going to use to make the inequality. All right, so first we have to define our variables. So let's call X the number of, I'll just make it t-shirts. And then that would make Y the number of sweatshirts. Okay, so with that in mind, the first constraint, he has $100 that he needs to spend. Okay, so if we take a look at it, was $5 for every t-shirt plus $10 for every sweatshirt, and you can spend up to $100, so less than or up to $100. There's the first constraint. Here's what he's buying, less than or equal to 100. All right, he has to spend a minimum of $50. Okay, so 5x plus 10y. That should be greater than or equal to 50. So you can spend 50 or more. So there is kind of the lower end of that. He wants to buy at least twice the amount of sweatshirts as he does t-shirts. All right, so the sweatshirts should be greater than or equal to twice the number of t-shirts because he wants to buy twice the number of sweatshirts. So this is our system of inequalities. Again, can you take words and write the inequalities? And once you get comfortable with that, we'll take a look at, all right, how do we actually solve this problem? How can we figure out what's the combination of t-shirts and sweatshirts that he could buy? So your assignment then will be to take a look at 2 and 3, and it's, can you take these words and write the inequalities?